Welcome viewers. In today's lecture, we are at the final segment of DAC, and in today's lecture, we are going to discuss the specification of DAC. In the previous two segments, we have studied the different types of DAC. The DAC follows certain characteristics that distinguish it from an ADC. The various characteristics of DAC that are specified by the manufacturers are resolution, linearity, accuracy, settling time, temperature sensitivity. Resolution. This is the smallest possible change in output voltage in the form of a fraction or percentage of the full output. For example, for an 8-bit converter, there are 2 to the power 8, which is equal to 256 possible values of analog output. Therefore, the smallest change in the output is given by 1 by 255 of the full scale output, which results in 0.4%. Hence, the resolution is 1 by 255 or 0.4%. Linearity. Linearity can be described as the increment in the numerical significance of digital input, which is equal to increment in the numerical significance of analog output. The linearity of a DAC is a measure of the precision of the converter. The linearity is an ideal concept as in actual circuits, the input-output relationship is never linear due to error in resistor values and voltage across the switches. The figure here states the output voltage of 3-bit unipolar DAC. Here, the horizontal axis states the input bit combinations with fixed interval separations in order of numerical significance, and vertical axis represents the analog output. The output voltage for each input is indicated by a dot. Since the DAC is not ideal, hence the dots do not follow a straight line. The linearity error between the dot is obtained from the difference between the output and the straight line and is denoted by epsilon. The change in normal analog voltage corresponding to the change equivalent to the LSB is indicated by delta. Now, epsilon is compared with delta to find out the linearity DAC. For example, the linearity of a commercial DAC unit is specified as accuracy. The accuracy of DAC is the difference between the actual output voltage and the expected output voltage. It is also specified as the percentage of the full scale output voltage. For example, if a DAC has 10 volt full scale output voltage and accuracy of plus minus 0.2%, then the maximum error of output voltage is 0.002 into 10, which is equal to 20 millivolt. Settling time. When the digital input at DAC changes, the analog output doesn't change at the same instant due to the presence of switches, active devices, stray capacitance and inductance. Therefore, the transients appear in output voltage and oscillations may occur too. This is shown in the figure. Hence, the time required for the analog output to change within half plus minus LSB of the final value, that is, after changing the digital input, is referred to as settling time. Temperature sensitivity. The analog output voltage varies with temperature. This is due to the temperature sensitivities of the reference voltage source, resistors and op-amp. It is specified by. In today's lecture, we have learned introduction to various specifications of DAC, a detailed description of various specifications of DAC. With that, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.